So now we are going to hear from Richard, who's Chief Marketing Officer and Chief Strategy Officer at Accedian, about securing the digital value fabric. Welcome back, Richard. Nice to see you.
Good morning. How are you today?
I'm well, thank you. You?
I'm doing well, and I have to say that's the first time on a Zoom call anyone has ever told me to turn my camera off. So I'll try not to take offense this morning. I'm on camera, of course. Good morning, everybody. Good afternoon. My name is Richard Piasentin. I have what I like to tell people is the best job in the world. I get to travel the world talking to our customers, thinking about the problems and opportunities that they're going to face over the next 2 to 3 years, and then I get to come back to the Accedian mothership, and through my product teams, I get to execute the solutions that our customers need. One of the things that I want to talk to all of you about today is securing the digital fabric, and that may sound like an odd title, but when we think about the complex ecosystems, even in the construct of the prior presentation that was discussing, the opportunities presented by private 5G networks, et cetera. When you look at the technologies involved in delivering those solutions, it is no longer a set of, highly static network architectures. It is a literal fabric of CNFs and VNFs all communicating, creating an ecosystem that in sum delivers a solution. And that creates great opportunity, as discussed in the prior panel, but it does create some challenges. So I'm going to talk a little bit about what these ecosystems require when it comes to trust. Now, hopefully, I can actually share my screen. This will stop other screen sharing. I'm assuming that's okay. Annie, can you just confirm that you can see my screen, please? Yes, okay, excellent. I got a thumbs up. That's pretty much the best thing I've heard from Annie so far today. One of the things I want to talk to the group about is something called multi-crash avoidance system. So we heard in the prior panel, autonomous driving is going to take some time, et cetera. One of the reasons is that, well, it's one thing to have an autonomous vehicle operating inside of, just say on highways as an example, or less dense urban environments. The issue actually comes when autonomous vehicles will be operating in environments where there are multiple types of users present. Typically on a highway as an example, there's just other vehicles, relatively easy to identify and to understand the trajectories of those vehicles. But pedestrians have as an example, have a terrible habit of doing random things. And so MCAS was envisioned by the group of companies that you can see here, and Accedian is part of that ecosystem, was envisioned as a infrastructure that provides effectively, you can think of it as providing a radar screen of threats being defined as something that the autonomous vehicle needs to deal with in its close proximity, over and above what that vehicle can sense with its own sensor suite. The easiest way I've found to explain this to people is to think about it in the construct of, just imagine the air traffic control radar screen that we see in movies all the time about aircraft coming in and out to an airport. Think of that, but localized to each vehicle. Now, this is a fantastic set of technologies in POCs now, built on the Mobile Edge X Edge ecosystem and incorporating technologies from Safari, Accedian itself, and I'll explain what we do in this. Solus, a sister company of Accedian's, who does high fidelity message buses, and again, the Mobile Edge X ecosystem itself. In order to implement a set of technologies like this, what ends up happening, and it was a little discussed in the prior panel, is not only do you have infrastructure that is provided by, as an example, the service providers like Deutsche Telekom or Telefonica, but you will be incorporating, think about the smart city and the smart city initiatives around infrastructure, et cetera. You will be integrating devices, IoT devices, into the ecosystem to provide more data for that radar screen. What's the situation with respect to the traffic lights? What are the CCTV cameras telling us, as an example? So if you have a pedestrian who doesn't have the sensor technology on their smartphone, another way to do identification of quote threat for the autonomous vehicle is use the CCTV camera feeds as a way of allowing AI to visually identify targets that are moving inside of the environment. When it comes to trust, why is that important? Well, if you start to think about what we're discussing here, you have, and this kind of goes to the fabric comment, you have multiple operators that need to participate because you need to bring in data sets from all of the operators in a particular urban environment in which this application is running. And then you need to be bringing into that edge ecosystem the camera feeds, as an example. So if you start to think about that from a threat perspective, number one, well, before I talk about threats, which we're all extremely enthusiastic about, I'll talk about performance. In an application like this, we need to synchronize the latency performance and the responsiveness of the entire system to the creation of that radar screen, as an example. This is a perfect 5G use case, although it's not 100% dependent on 5G. 5G optimizes it. And also explicitly, it requires edge processing. The kind of latencies that are required for a system like this will require edge. So now you think about it. I have the requirement for edge compute. I have the requirement for multi-operator participation in the data sets. And I have to incorporate infrastructure that comes from, it's not infrastructure that is, heavy metal, hardened, not necessarily even 100% tested to the same kind of criteria as the rest of the network infrastructure. And what happens is, in an environment like this, you need to have a performance broker, and the Accedian platform provides that in this ecosystem, which if anybody's interested, they can reach out to me and I'll explain in more detail. But you also have to be watching for all transactions across the infrastructure for threats. And the reason is, if you think about threat surfaces in general from a security perspective, so when you think about your security posture, you're only as good as the weakest link in your chain. And the weakest link in the chain typically are bits of infrastructure that are IoT devices, CCTV cameras. We're all familiar with the botnets, et cetera, that have been exploited over the last few years around corrupting even people's home gateways, as an example. These systems are built sometimes on very old operating systems with multiple unpatched issues. Typically, they'll have default configurations that are available that have never been changed. They create these IoT devices, which are part of intelligent infrastructure, create soft spots in the security posture of the application. So it is critically important when you're thinking about applications like this. We just use this as an example. You need a low latency, real-time performance system that's watching for all the transactions and the performance of the VNFs and CNFs in the ecosystem, but you also have to be watching for security threats across that environment as well. And you can't count on doing it with endpoint security. An IoT camera cannot run a full endpoint security solution. Just some fast facts for everybody. I don't think I need to explain what the consequences are of a poor security posture. As we've all recently been, particularly those of us here in the US, I am Canadian, but I do live in the US. Our entire government infrastructure has been put on high alert as a consequence of the most recent SolarWinds hack, which many or most of you I'm sure have heard of. One of the things that's critical in a hack like that is you have the endpoints or the systems involved have themselves been corrupted, administrator rights were granted, and then the threat actors start deploying payloads into the network, and they move across the infrastructure. That's the general sort of tactics that are used. At the point that you are compromised, you can no longer count on your firewalls and you can't count on your endpoint security. You have to be watching what happens on the wire. Like I had one of my team members tell me, the lowest common denominator and the best common denominator in a security system is the fact that for something to be significant, it needs to go across the network. And so your security profile or your security posture needs to incorporate watching what's happening on the wire. Again, I don't think I need to explore these statistics in any level, but with respect to the SolarWinds hack in particular, the only way to detect that hack subsequent to the primary infection vector is by watching for abnormal behavior on the wire. So how does an NTA work? I would encourage everyone to reach out to me who's interested on how this works, but essentially you need to have a suite of sensors deployed throughout the virtual and physical infrastructure. These are all software sensors, very lightweight, and just for the record, at least with respect to the Accedian solution, we don't, as an example, we don't penalize our customers for getting visibility across their environment. So we don't charge by sensors. So you deploy the sensors everywhere you think, everywhere inside of your infrastructure so that you have complete visibility of all transactions across your network. And then you analyze those transactions for anomalous behavior. In Accedian's case, in our NTA, the same sensor that we use, same software sensor that we use to acquire the network data is used for two reasons. One, to do the performance system that I was talking about in the MCAS example, but then we use the exact same data set. We extract the packet insight. So for every packet that goes across the network, we pull key characteristics from those packets, and we use that to generate the insights around both performance and also around, we use that feeds our security AI and ML systems to analyze the traffic for security threats. Generally, the NTA market, sometimes called next generation IDS, sometimes MDR. This is a very new set of technologies. There's been variations for many years, but in terms of large scale watching for anomalous on the wire across a large scale enterprise or service provider environment is a new segment. I do believe, as a consequence of what happened with SolarWinds as an example, that it's not, in 2 years from now, it's not going to be a question to a CIO as to why they want to spend the money they want to on deploying a NTA, but rather the question that boards and CLOs are going to be asking is, why haven't you deployed one already? Effectively, an NTA is the last line of defense in a security posture. It says, my castle walls have been breached. What are my internal damping systems and control systems to watch for corrupted end devices happening inside of my network? So when you think again about an application, and even if it's just one operator, but it becomes even more complex and important in the construct of multiple operators, you need two things effectively. You need a consistent performance system so that the applications can consume data sets from subscribers and devices across multiple networks. And you need a common trust model around security, watching all of those transactions, one for performance, obviously, for a high performance application, but almost as importantly in these environments, just imagine the chaos that would ensue if hackers got access to one of these control systems. In fact, there's many movies that we've all watched in which people do that, okay? This is kind of real. It's not kind of real, it is real. and it needs to be defended against. So your application system needs to provide you both of those functions. So if anyone out there is contemplating deployment and management of these types of complex ecosystems, particularly ones that are involving infrastructure which isn't quote unquote carrier grade, security threat detection and performance, like I've said, across any hybrid cloud environment, which is a whole subject unto itself, please give us a call. We can provide solutions across all this, and we have some experience with our partners on what it takes to deploy these kinds of solutions. Thank you very much. And I don't know, Annie, if we have any questions.
Always fascinating, I think. It kind of scares you, but it's great that we have some answers for dealing with it. But so do you need sensors for both performance and security in the model, the trust model that you describe?
Annie, thanks for the question. No, we use the same sensors. So we have a very lightweight, we have a suite. Accedian has a suite of sensors depending on the different applications, et cetera, but specific to security, we have a suite of passive layer 2 to layer 7 sensors, very lightweight, and those sensors are used for the same data set. So if you just imagine a sensor deployed either into your AWS instance or deployed into your vSwitch, those sensors extract a set of data that it reflects all of the transactions that are happening. Just to be really, really specific on this, by the way, it's 24/7, all packets. We don't do net flow, we don't do sampling, we don't do summarizing. We are looking at every single transaction across the network. That same data set that we're extracting from that sensor is then used by 2 different workflows in our analytics system. We have a workflow which is specific to performance. So it's analyzing those packets and it's saying, okay, here's what's happening from a performance perspective. Here's what's the problem in the infrastructure. Here's the correlation to, particular network elements that aren't performing the way they should be. And then we have a different workflow that is analyzing that same data set and watching for anomalous behaviors, right? So a complete security workflow. Both are working on the same data set.
Presumably the latency from the analysis is absolutely minimal, because it needs to be super fast to be useful.
Absolutely. So one key design criteria for our analytics platform, which all of this is based on, was operating in real time, number one. And number 2, we built a platform first, Annie, then we built workflows on top. So if you actually look at the workflows that a human would consume as an example, in our system, those are HTML5 applications that are then querying our platform. The reason that's important is that in this cloud native world that we're all in, and when you think about the highly dynamic nature of this cloud native world, what's most important is that another application can actually be plumbed into the performance system. So that real-time information, KPIs, analytics, correlation around performance can be fed through an API into an application itself. To give you an example, in the MCAS case, while it's really vitally important to provide information on the folks that are responsible for operating and deploying that infrastructure, what's as important is to provide a performance feed to the application itself so that it knows when to say, just as an example, I can no longer perform the way you need me to, go to plan B. It's absolutely critical. I mean, it's a very trivial case, so the application knows when to turn itself off, but thinking about this kind of an environment, just this kind of use case, critically important that the application itself is plumbed into the performance that end users or endpoints are experiencing.
So we have another question here, Richard. In terms of network traffic analytics, is it necessary for them to be coupled with the enterprise SOAR framework?
Well, that's a great question, actually. So whoever went out there,
Wasn't
please send
mine,
me.
but anyway.
Yeah. Please send me an email. Yeah. So does it have to be implemented into a SOAR or a SIM? Typically, the answer.
Hmm.
I'm sorry.
Coupled with was the word used. So
Yeah. Coupled with. Typically, they would be, because it's one thing to know it happened. It's really important to do something about it. Okay, so the Accedian system, as an example, is not a SOAR or a SIM. Okay, we are a fit for purpose NTA, as an example, and we would typically be plumbed into the larger response framework of an enterprise. That said, for small, medium-sized enterprises, as an example, now this is kind of leaving the topic of the talk a little bit, but for small, medium enterprises, we have a workflow that is very sophisticated. It follows the MITRE framework, and it provides not just an event feed, but rather we provide a incident response function inside of the platform itself. So for many enterprises, our solution itself is sufficient and is orders of magnitude better than what they're doing already. However, for very complex security posture environments, we absolutely would recommend, if you have a SIM, please plug us into it so that your response framework can be coordinated.
horses for courses, really, then.
Absolutely,
Right,
thank you. That's a very efficient English expression for that.
Okay. Another question is, with the multimodal crash avoidance system, is that deployed today?
It is in POCs, yes.
Okay, so it's proof of concept only.
Yes.
Okay.
Yeah.
And what other use cases do you see as being a big challenge with these complex, massive kind of multi-environments?
Oh my, how much time do we have today? Okay, so I'll just give you an example. My second favorite example, when I'm talking about private 5G, which I know was partially the topic of the prior panel. So we're super excited at Accedian about the opportunities presented by private 5G. I would dispute perhaps the fact that that some of the deployment options are unlikely to happen. I actually think all of the different deployment options are likely, including all the way up to, CBRS or I think it's monitored use, radio bands, direct deployment of 5G private networks for typical enterprises. I actually think when you fast forward 3 to 4 years from now, you're going to see many enterprises making a decision between, do I broadly deploy Wi-Fi 6 or do I deploy private 5G? And I think the decision is going to come down to, do I need a network environment where quality of service and guaranteed quality of service is important for my applications? I'll give you my second favorite example, which is when you think about augmented reality in Industrial 4.0, you think about Factory 56 as an example, environments, folks are deploying. So I'll have you think about, I should probably not use a brand name in this, but that doesn't matter. Just imagine Rolls-Royce as an example in the UK, building those jet engines that they were talking about that developed the 1 terabyte of data for every flight. So just imagine the factory where that's happening. So imagine the master tech that has to go and diagnose a particular part that has reported there's a problem. There's absolutely a use case for industrial AR where instead of carrying around 200 pounds of manuals to figure out where they go on the engine in question, and this technology all exists today, for the record. Okay, this isn't science fiction. And I'll use the example, HoloLens. I hope everybody on this call is familiar with the HoloLens. If not, please go and find out about HoloLens in various iterations of technologies like that. That is our future, just waiting to happen. But HoloLens, AR glass, it allows it would allow for the application to present to the master tech on top of their visual field which part it is that they have to go and access, as opposed to carrying the 200 pounds of manuals all over the place, or having to go back to a different central office to go and find, thinking about, you know, worker productivity, et cetera, having to go back to go and get different manuals when you realize that you don't know how to get the screw that's on top of the thing that's holding back the thing that you have to get to. Again, I'm making this a little bit silly, but that use case is real. And when you think about that application, one of the challenges with AR and VR environments is if you're not responsive enough, you make your users sick. So much like the MCAS system that I was talking about before, where it's almost as important to be able to tell the application when things aren't working so that it shuts itself off. Just think about that industrial AR application. You could over provision the heck out of it to make sure that it's performant. But if something happens and the refresh is not happening at a rate that is required by the way a human brain works, you're going to make your master tech sick. So it's just another example of where, for that kind of high performance application running over a private 5G network using edge compute in the enterprise, has to be performant, and it needs to be monitored.
Richard, thank you very much. I'm sorry we've come to the end of our time, but we have. That was great, and see you soon, I expect.
Thank you very much, Annie. It was nice seeing you again.
Thank you very much.